In this problem, we have some data on 3 candidates that we've been collecting, and we want to use a weighted average of t-scores to determine who the most qualified candidate is for a position. So we have 3 candidates, Doc, Grumpy, and Dopey, and they have a cognitive ability test, a skills test, and a second skills test. And the first two are weighted at 40%, and the second is weighted at 20%. And we've got the scores. Doc did really well on cognitive ability. Dopey didn't do too well. On the first skills test, Dopey didn't do very well, but he did very well on the second skills test. And Doc and Grumpy were about even. Now here we've got the means and the averages for the cognitive ability test and for the 2 skills test. So we'll be able to use these to convert them into z-scores, because otherwise the skills test 2 has such large variability, the numbers are higher, they would dominate. So if you were just to add these together, it would be mainly the skills test 2 that would be the one that would influence everything. So let's create a z table. So let's have another. We got criteria, and we will have cognitive ability. You can have the skills test 1, skills test 1, and skills test 2. And over here, we'll copy the weight again. Weight will be 0.4, 0.4, and 0.2. And let's change this into a table. Insert table. That looks good. And we've got Doc and Grumpy and Dopey. Oh, Dopey spelled wrong. He's not going to be happy. And let's see if we can copy those colors there. Let's see if we can find something that's similar to that. Is that, yeah, that looks pretty good, except it's white. So let's get that color there, the color. And, oh, no, that was, let's change the background to that. Let's change the lettering to black. Well, let's do white to be consistent. Now we want something dark. Let's go for some blue there, and over here we'll go for this blue also. Oh, that looks just like above, so that's good. So we want to calculate a z-score for all of these guys, so we will use our formula for z. Z equals raw score minus mean, close parentheses, divide by standard deviation. So for Doc and cognitive ability, we're going to say that z equals, open parentheses, H12 is Doc's raw score, minus, we want the mean for the cognitive ability, so that's going to be D16. Now we want the means to always come from column D, so we're going to do $D, but it's going to change lines for cognitive ability skills test and skills test 2. So I'm just going to do $D16 and let that 16 change, and divide by the standard deviation, which is an F16. So I'll do $F, but not $16, because I want 16 to change when it goes down to lines. And we set that for all of them, and we get the scores for the z-score for Doc, and we can pull this over here, and I'll calculate the z-scores for everybody there, and then we can pull it down, and it'll calculate them for everybody there, and let's round them off to 2 decimal points. So now we've got the z-scores for everybody. Let's label that z-scores. And it figured out that that wasn't part of the table since it was above the headers. So now we've got the Z-scores, and we so it says first create a table of Z-scores using the appropriate means and standard deviations, and then create a table of T-scores. Let's do the same thing. Let's see if we can just copy this first part of the table. Okay, Control copy. Let's put it down here. Control V. Okay, now let's add doc. Oh, doc didn't get added onto the table. Oh, that's because this isn't a table yet. Let's change it into a table. Insert table. Okay. Now when we do doc, oh, it still didn't enter in there. Let's type it again, see if we can get doc to join on. Aha, now he has. And we're gonna get Grumpy to join in. And we can get Dopey to join in here on the table. And to get the T-score, we're going to use the formula T-score equals 50 plus 10 times Z. So doc will be equals 50 plus 10 star, and his Z-score is H22, and press enter, and he has Z-score of 59.09. And let's see if we can pull this over for everybody and then pull it down. And there we have Z-scores for everybody, and let's round those off. And so that gives us number. Okay, so now we can see the T-scores for everybody. And Doc did best on cognitive ability, and Dopey did worse on the skills test 1, but he did well on skills test 2. So let's look at total weight. That's going to be, let's undo that. Undo automatic table expansion. Let's do auto sum here. And so that will be total weight of 1. And so here we're going to do weighted averages. And we're going to do the sum product command equal sum product, and then open parentheses. And the first array is going to be the weight. So that's going to go from G29. Well, let's keep the dollar on the G, $29 ... to $G, $31, comma, and then we're going to have doc's array of data. That's H29. So H29 ... to H31. No dollar signs because we're going to move this over for Grumpy and Dopey, and we're going to divide by the total weight, which is G32. We want $G, $32, because that always stays constant there. And then close parentheses. And we found a typo in your formula and tried to correct it. Sum product $G29 to $G31, H29 to H31. Well, it's saying to put just one dot in rather than two. Okay. And that came out to 57.24. That looks good. Let's draw it over there. And we get the Z-scores for all, or the T-scores for all three. Let's round them. And so Doc has 57.24, Grumpy 53, and Dopey 39. It looks like Doc is our top candidate. He has the highest weighted T-score by quite a bit, by 4 4 points. That's like 4/10 of a standard deviation. And poor Dopey, even though he did well on that second skills test, he's quite a bit behind in the other things. But Doc is our top candidate.